the secondary memory. So before we get into the secondary memory, first let me explain what this secondary memory is. Why it is known as secondary means, for the processor, this memory is always the later option. What is the first option? Primary memory, means RAM, ROM, cache memory. They become the first priority for the CPU whenever it wants data or instructions. So, for the processor, from the processor point of view, this memory is the later priority. That's why we are calling this as secondary memory. And it has another name called auxiliary storage. This memory is also known as what? Auxiliary storage. Auxiliary means additional, excessive. As this is the excess memory, from processor point of view, processor want primary memory for its operation. That is what the sufficient memory for the processor to work. But than primary memory, we will be incorporating this memory as additional memory, excess memory. That is the reason why this memory is also called as auxiliary storage. And there is another name for this memory, that is backup storage. What is the other name for secondary memory? Backup storage. Backup means safe copy, right? So if or today everybody are uploading in the Google Cloud, that means either you may store in your personal hard drive or you may store in the Google hard drive. Both are secondary memories. So this is what we say backup, safe copy. When we need to maintain any data for a long time as a safe copy, then we prefer this memory. Henceforth, it is also called as backup storage. Now, what are different types of secondary memory? Basically, there are two types of secondary memory. They are sequentially accessible devices, sequentially accessible memory devices, and randomly accessible memory devices. Randomly accessible memory devices. These terms are self-explanatory, isn't it? That means the data in this memory can be accessed in order. For example, you might have got an idea or you might have seen audio cassette. Currently, their usage is very, very less. But earlier, few years ago, maybe like 7 to 10 years ago, we used to use audio cassette, where you will have 3 songs on one side, 3 songs on another side, right? So you are supposed to play those songs in the sequence. You cannot directly play 5th song or 2nd song, isn't it? So this kind of memory is called sequentially accessible. Because of that sequential access nature, they got outdated. There is another name for sequentially accessible memory, that is tapes. What is the other name for this? Tapes. And randomly accessible devices are also called as disks. So randomly accessible devices are the contrast to this, isn't it? So randomly accessible devices in which the data can be accessed in any order. No need to follow the sequence. That's why these are called randomly accessible. So, basically secondary memory is classified into two types: tapes, disks. Now, what are different forms of disks available? There are again three forms of disks. Guys, those who are watching this, you please maintain a book, a paper and pen along with you, and you start writing down these points in your notebook. Okay? It works like lecture notes for you, so you may refer it. The hard copy, maintain the hard copy of the notes. Okay? Right. So the disks are basically classified into three types as floppy disks, optical disks, and magnetic disks. Okay? Floppy disk, optical disk, magnetic disk. Floppy disks used to be available. Why I am calling it as used to be? Because today we can see floppy disks very rare. Their usage is almost got stopped. Nobody using floppy disks. But in fact, these floppy disks are the fastest disks, we can say, secured disks we can say. But why we are not using them in the current technology means because of their size limitation. What is the drawback of floppy disks? Their capacity limitation. How? We used to have three different forms of floppy disks: 8-inch floppy, 5.25-inch floppy, 3.5-inch floppy. What this inch indicates? This is the floppy, how it looks like in the square shape externally with the black or blue fiber case or plastic case, you say. When you remove this case, inside the floppy you can see the circular film. So the diameter of this disc used to be 8 inches, 5.25 inches, 3.5 inches. What is that inch indicates? The diameter. In a 8-inch floppy, you can store around 1000 kilobyte of data, or approximately you can say 1 megabyte data. And in 5.25-inch floppy, you can store 1.21 megabyte data, and in 3.5-inch floppy, 1.44 MB of data can be saved. So what is the max you can store in a floppy? 1.44 MB. Mercy, you just joined, right? Did I miss anything? Mercy, do not worry, you did not miss much. We have just started. I have just introduced different types of memory. However, this will be recorded and will be there in the YouTube as well as in your app also. After the session, it would be saved in the app. So you can just replay that and you can see that. Okay? Krish, 1 megabyte equal to 1024 kilobytes. Yes, no doubt. Yes, it is. That's why I have written approximately. I know, Krish, it's not exact equal. So approximately, to remember easily, you can say 8-inch floppy size is 1 MB. Okay. So the maximum, how much can be stored in a 3.5-inch floppy? 1.4 MB of data. 1.44 MB of data. So 1.4 MB is today very less, isn't it? Because even if you take a small a song also, .mp3 song also, its size is in 4 MB, 5 MB. So 1.4 MB floppy means it is no way sufficient today. That's why, because of that capacity limitation, floppy disks got outdated. And optical disks, under these only we will have CD, DVD, Blu-ray discs. Why these are called optical? Because they work with light. The reading or writing into these CD, DVDs happens using light waves. That's why they are called optical discs. And what is the capacity of a CD, guys? The capacity of a CD is 700 MB, 700 megabytes, and the DVD capacity is 4.7 gigabytes. And Blu-ray discs are available in multiple forms like pen drives, 8 GB, 12 GB, 16 GB. So Blu-ray discs are available in multiple. Okay. However, for our gate perspective, among secondary memory, among disks, which we should focus much, that is magnetic disk. This is what also known as hard disk. This term is very much familiar for everybody. Hard disk. Its technical name is magnetic disk. So in our gate, we will be having the questions from magnetic disk or hard disk only. So let us discuss about only magnetic disk in detail. So if you see the magnetic disk or hard disk here, the inner layout of hard disk looks like this. If you see this, this is what? This circular plate is what we call as a platter. So inside the hard disk, we will be having a circular plate called platter. This is made up of with glass, plastic and fiber material together. They are mixed at certain proportion and this circular plate gets formed. And please remember, in any hard disk, you will not be having a single platter. In any hard disk, you will be having multiple platters. Okay? So you will be having minimum 2 platters, and currently you can say up to 8 platters we are using in today's hard disks, but it is not fixed, it may even increase. Like 500 GB hard disk may use 4 platters, 1 terabyte hard disk may use 6 platters. Like this, as the hard disk capacity increases, this number of platters may increase. Okay? Now, each platter will have 2 recording surfaces. Each platter will have what? 2 recording surfaces. Okay? So, suppose if this is the see, I think everybody can see this paper, right? If this is the platter, like how we write on both sides of any paper, we can write in the same way. Each platter has the ability to record the data on both sides. So on the top side as well as on the bottom also you can record. So we call each platter is having 2 recording surfaces. Okay, I can see some question. Aarti, sir, will you take numericals also? Yes, we will be taking numericals also. So first, before going to problems, you should understand how it works, isn't it? That's why. So each platter will have two recording surfaces, and you can see all these platters are mounted on a central location. This is what you call as spindle. What is the central location of any platter? We call as spindle. So all platters are mounted. Sir, when multiple platters are there, how they will be mounted? Just like you might have seen the CD rack. There will be a stick on which all the CDs are mounted one over the other, isn't it? In the same way, all platters are mounted over the central location called spindle. Okay? That is called spindle. And every surface is partitioned into these concentric circles. Like if you take this as the platter surface, this is one surface. Every surface is partitioned into concentric circles. These are what we call as tracks. And each track is further partitioned into sectors. See, this black color what I am using, these are, you should assume as what? Sectors. So, any surface, I am telling, any surface, that means top as well as bottom, both sides will be partitioned into tracks. Tracks are further partitioned into sectors. Please make a note of this point, that the universal capacity of a sector is 512 bytes. One sector capacity is 512 bytes, which is a universal constant. Like how pi is equal to 22/7. In the same way, one sector capacity is 512 bytes. Very, very important to remember this. In your academics, you may get this as some bit in your internals as well. Okay? Right. So, every surface is divided into tracks. Tracks divided into sectors, and what is one sector capacity? 512 bytes. Now, how the data is inserted on this surface, or how the data is extracted from the surface? Here you can see some arrangement. Here you can see the arrangement, guys. Here you are having a read-write axis. Here you can see this, isn't it? A read-write axis. One end of that read-write axis is fixed here. The other end of read-write axis is having, read-write head. Read-write head. So this is the component which will write data, that means insert data into this surface or extract data from the surface. Okay? And if you observe this read-write axis, this can move, observe this, this can move only at a 30-degree angle, isn't it? As it is fixed here. So, you observe, please observe this. The read-write axis is fixed here and it can rotate till this. So, if you carefully see, at any given time, the read-write axis can cover exactly what? Half track. you take any track, the read-write axis exactly can scan, read or write without disk rotation. How much? Half track it can cover. Now we will have definitely a doubt. What if the data is on the other half? Let's say we have the data, the case 1 is the data is to be read or to be written in the bottom half, as our read-write axis is capable of scanning, covering these sectors. Without any movement, it can directly read or write, isn't it? But case 2 is, what if the data is on the other half? This cannot go in that way. It cannot cross the spindle. Then what to happen? The disk rotation should happen, isn't it? The disk should rotate. So for the disk rotation, under the spindle we are having a motor, that is what we say spindle motor. Under the spindle we will have a motor called spindle motor. Okay. Now whenever the disk is rotating, generally the axis will not be on the disk, will not be in contact with the disk. In contact with the disk. Okay. Then while the disk is rotating, the axis should come out of the disk. That's why it is moving. So for its movement, here we will be having a motor called stepper motor. For the read-write axis also we will have a motor called stepper motor. Okay. Akshay Kumar, but in the GATE exam, difficult questions, how this will help? Akshay, without understanding how it works, how do you understand any GATE question, Akshay? Huh? Okay. So this is how the hard disk act with the help of axis, head, it will read or write the data. Okay. Now a big doubt would be how these motors know when to rotate, when to stop, how this read-write head know whether to read the data or write the data. For that, here we will be having a logical circuit board. Observe this area. This is what you may call as read-write logic, or you may call this also as controller. You may call this also as what? Controller. So this logical circuit will guide or will give the signals to these motors, axis, head. So this will be controlling all the operation. Okay. Now here you see, before that cylinder concept, if you see here, you might be thinking there will be only one read-write head, that is for the top surface. No. Please observe this. If these are the surfaces or these are the platters, see here I have 3 platters. This is the top, this is the bottom. Similarly, this is the top of second platter, this is the bottom of second platter. like this, if you assume there are 3 platters, please see this. Please observe this diagram. We are having the read-write head for the top surface as well as for the bottom surface. Here you can see this arrangement. So what you should understand is each surface is having a dedicated read-write head. There will not be a single read-write axis or read-write head for all the hard disk. For every surface, there will be a dedicated read-write head. Understood? Please observe this diagram once, guys, so that you can understand even more better. Now, okay, Jaydeep was asking how many surfaces. Jaydeep, number of surfaces is always 2 times that of number of platters. Here if you say 3 platters, 6 surfaces, because every platter will have top surface, bottom surface. Got it? Now, assume this is the spindle. This is the top surface of platter 1. Carefully listen, guys. This is the bottom surface of platter 1. That means top, bottom. These two together single platter. This is the top of second platter. This is the top of bottom of second platter. Okay? Please observe this. Now, all first platters, first tracks, all first tracks together. That means track 1 of surface 1, track 1 of surface 2, track 1 of surface 3, track 1 of surface 4. All first tracks together we call as one cylinder. Similarly, all second tracks together we call as one cylinder. So, what a cylinder means here? What a cylinder means? The collection of, you can make a note of the definition also. What is a cylinder? Collection of single track sectors from each surface or every surface. That means from every surface, if we collect one track sectors, that collection of similar track sectors from every surface is called what? Cylinder. Okay? Let me take some doubt. Mercy. Sir, top and bottom are on the same side? Top and bottom are on the same side. How they are on the same side? See, please observe, platter is just like a paper. This is the top, this is the bottom. This is having the read-write head, this is also having the read-write head. Separate read-write heads. Merci. Okay. So, if you observe here, one cylinder will get one track from every surface. Right? So, let's say all first tracks together is first cylinder. All second tracks together is second cylinder. Like this, can I say number of cylinders is equal to what? Number of cylinders will become what? You tell me, guys. Students, answer this question. All first tracks, first cylinder. All second tracks together, second cylinder. All nth track together, nth cylinder. So number of cylinders is equal to what? Number of tracks. Very good. Number of tracks. This is important to remember. That you can understand more better with the diagram here what is shown. So this is what? All one track information from every surface is what you call as cylinder. Cylinder. Or here you can see some other image related to that. Here you can observe this. This is one track, first track. Here first track. So first track of that surface and first track of this surface. This is what? Cylinder 0. Similarly, the next track means second track from every surface. This is one cylinder. I believe you understood what is cylinder concept now. Okay? Right. Now, how do we number the sectors? Here you can see. Let us say there are 16 sectors per track. Let's say there are 16 sectors per track. Sir, will every track will have same number of sectors? Yes. Please observe this. This is the innermost track. This is the outermost track. Okay? As you can see this, the innermost track is small and the outermost track is big. So, it is very common perception that innermost track will have less number of sectors because its capacity, area or circumference, whatever the term you use, it is less. Outermost track will have more number of sectors because it is big one. But please remember, every track, each track will have same number of sectors, equal number of sectors. How that is possible? This is possible with the density concept. Less area, more volume. Let's say the innermost track is having 4 sectors. The next innermost track will also have 4 sectors. The next innermost track, the next track also will have 4 sectors. The next track also will have 4 sectors. Please observe this. Next one also will have 4 sectors. So if you observe, the innermost track, where the area or the volume of this track is less, but number of sectors are more. So the recording density, is high where the recording density would be high? In innermost or outermost? Tell me. In innermost or outermost, where the recording density will be high? Give me the answer, students. Smallest, innermost. Good. So, this is earlier, this was one of the point which helped to solve gate question, means in the 2004 year. That's why, Akshay, if you are on live, you can understand. So, understanding the concept is required to attempt any gate question, so that the question would be understood easily, completely. Okay, right. So, the recording density is high in the innermost track, which is low in the outermost track. So, because of density variation, every track will have same number of sectors. So, I am assuming there are 16 sectors per track. Okay. So, please observe, these are numbered. Here actually in this diagram it is numbered from 1, but please remember numbering, either you number cylinder or you number surface or you number sector, any numbering starts with 0. Please remember that. In this diagram it is started with 1, but understand any numbering starts with 0. For your simple understanding, I have represented here with 1. So, let's say there are 16 sectors. So, once this one track is filled, the next 16 sectors will be occupied where? Will they occupy in the same surface? No. They get occupied in the next surface first track. Because like this 17, 18, 19, 20, 21, 22, 23 and so on. Like this. So let me show you one example for this. Let's say one platter. Of course, there will not be one platter. There will be multiple platters. Okay, even if you want, let me draw the other one also. And you assume there is other. Okay, just for it to be visible, I have took long circles. Now, let's say there are 4 sectors per track. Assume there are just 4 sectors per track. So, the first sectors will be like this 0, 1, 2, 3. Okay. Let's say there is some file. That file size is, let us suppose, 3 kilobytes. 3 kilobytes means 6 sectors, isn't it? Because one sector size is 512 bytes or half kilobyte. One sector size is half kilobyte. So for the file, how many sectors are required? 6 sectors. So in those 6, 4 sectors got occupied here. Four sectors got occupied here. The next 2 sectors would be where? Not on the same surface. They will be on the next surface, first track. Let's say this is file 1. file 2, there is another file. Let us assume its size is 11 kilobytes. 11 kilobytes means how many sectors? 22 sectors are required. Right? So these 22 sectors, where they will be? First sector, second, 2 sectors are over. Please observe the numbering. Numbering continues. Or let me take this as some 5 kilobytes just to make it simple. So 10 sectors are required for this. So 2 are occupied here in the 10. Next 4 would be on the next surface. 9, 10, 11, 12. Right? Assume there is another surface. Here you can see that. This is the another surface. Just understand there is a connection. Now, what would be the next one? 13, 14. Sorry, here the numbering should be like this. Because we have started with 0. Because we have started with 0, 0, 1, 2, 3, next number should be 4, 5, 6, 7, 8, 9, 10, 11. And here they should be 12, 13, 14, 15. So you can understand this now. So 0, 1, 2, 3, 4, 5, 0 to 5. These sectors are for the first file. Then sector number 6 to 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 6 to 15 are file 2. Now if you want to store the next file, where it will be? All first tracks are filled, right? So now the second track will be initiated. This is called cylinder concept. This is called cylinder concept because the data is not stored track wise. Like one track is filled, very immediate track, no. Cylinder wise. That means one track from one surface, one track from next surface. Like this, all surfaces, one track should be filled. Okay? Now, sector numbering. That is what the concept. The sector address. Did you understand the sector numbering now? Sector numbering continues. So here 12 to 15. The next number would be 16, 17, 18, 19, 20, 21. Like this. Okay. Now, please remember sector address. Address is different, number is different. These are the sector numbers. Now, sector address. Always sector address is represented with 3 values. They are represented as a triplet C, H, S, where C indicates cylinder number. You can make a note of this. Every sector is represented, address is represented with 3 parameters. C, H, S. C means cylinder number. H means surface number. S means sector number. So guys, if I would like to write the address for, let us say, for this 18th sector. For the sector 18, I would like to write the address. How I will write? C. It is in which cylinder, guys? It is in the second cylinder. Numbering starts with 0. So second cylinder will have what number as C? 1. Right? So this is all 0th cylinder. This is first cylinder, means cylinder 1, cylinder 0. So the second cylinder, the 18th sector is, sector 18 is on the second cylinder. That's why C is 1. And it is on which surface? Very top surface. In our terminology, first surface. So what would be the number for that first surface? 0. Any numbering starts with 0. Now, on this surface, this 18 on this surface, on this cylinder, this 18 is which sector? 16, 17, 18, 19. That means first sector, second sector, third sector, fourth sector. Please understand, on this surface, on this cylinder. Okay, so this is the third sector. So third sector will have number as what? 2. So let me write another. Suppose I would like to write the sector address for 6. For the sector 6, I would like to write the address. So what is the cylinder number? It is in the first cylinder. So what is the C value? 0. Surface. First surface, second surface. The 6 is on the second surface, isn't it? So second surface will have the number as 1. Surface 0, surface 1. And on this, it is which sector? 4, 5, 6, 7. On this cylinder, on this surface, first sector, second sector, third sector this is. So what would be the sector number? 2. And let me write the sector number for 25. So what is the cylinder number? First cylinder. So cylinder number is, second cylinder. So the cylinder number is 1. Surface 1, first surface, second surface, third surface. So surface number would be 2. Here it is 1, 2, second sector. So the sector number would be 1. Right? So you should practice this sector addressing, sector numbering. You also take, you yourself draw the spindle, draw cylinder, or number of tracks is your wish. You take some 3 tracks or 4 tracks. You give numbering and you try to write the address for randomly for some sectors, because it is very, very important. Okay? Got it? Right. Now, we have one gate problem. Today we will discuss just couple of gate problems and we will conclude the session. This is one gate problem which is in 2007. In the year 2007 we have got this gate problem. What is that? Consider a disk pack with 16 surfaces, 128 tracks per surface and 256 sectors per track, 512 bytes in a sector. So disk specifications are given. the capacity of the disk pack. Okay, before that, Krishpala, sir, why numbering starts with 0? Krish, disk is used in computer. Disk will be communicated with CPU. We know computer numbering, processing numbering, binary numbering always starts with 0. Okay. Veer Pratap, because one sector is half kilobyte. Okay. Yes, how you are calculating number of sectors from file size? We know one sector is half kilobyte. So if the file size is 6 kilobytes, 12 sectors, 10 kilobytes, 20 sectors. Simple. Okay? Right. So let's see this problem. Disk specifications are given. 16 surfaces. 16 surfaces, 128 tracks per surface, 256 sectors per track, and 512 bytes per sector. So now we want what is the capacity of the disk pack is dash megabytes, and what is the address length for every sector, how many bit address should be given. I will show the question once again. You can just quickly see this question. It's a 2007 gate question. So here we are supposed to solve two questions. It is equal to couple of questions. You should calculate the capacity of disk pack and you should calculate the number of bits required to specify a sector. So how to calculate the capacity of disk? The capacity of the disk is multiplication of all, isn't it? The disk is having 16 surfaces. Every surface is having 128 tracks. And every track will have 256 sectors. And every sector is having 512 bytes. Right? Now, while solving secondary memory questions or memory related questions, try to express the numbers in terms of powers of 2. That would be easy to resolve. Okay? So, let me write this as 2 power 4, 2 raised to 7, 2 raised to 8, 2 raised to 9 bytes. Okay? And this is completely, if you keep adding all this, it would be 2 raised to 28 bytes. So can I write this as 2 raised to 8 multiplied by 2 raised to 20 bytes? Why I am writing 2 raised to 20? Because 2 raised to 20 is equal to megabyte. We want the result in megabytes. So it is 256 megabytes. So what is the capacity of the disk pack? 256 megabytes. And what is the second question? How many bits are required to address the sector? So what you should calculate for this? Number of sectors. Total number of sectors. It's not just for one track. all over the disk, how many sectors are there? That we should calculate. How many sectors are there all over? There are 16 surfaces, 128 tracks, 256 sectors on every track. So total sectors would become 2 raised to 4, 2 raised to 7, 2 raised to 8. So 2 raised to 19 sectors are there total. So when there are 2 raised to 19 sectors, how many bits would be required for any sector? 19 bits. When this is 2 power I bits are required. Like when we have 4 sectors, 2 bits are sufficient. 0, 0, 0, 1, 1, 0, 1, 1. Isn't it? So if you have 4 sectors, you may give 2 bits. Like if you have 8 sectors, 3 bits. So if you have 2 power I sectors, I bits are sufficient. So when you have 2 power 19 sectors, 19 bits are required. That is the answer. So what is the answer for this question? 256 megabyte and 19 bits. Simple question, but it's a gate question. You got this in 2007 gate.